Hello, everybody. I'm just going to quickly show you a simulation of a simple problem that we solved today. We had a 2 degrees of freedom system, a spring and mass, and here is the system of differential equations in matrix format, which we use that simple formula to find the natural frequencies and the corresponding ratio of A to B, the amplitude of vibration, which if we write them in a vector format, we call them the mode shapes. Here is the first mode. If I show the simulation over here, as you see, let me maximize it. The two masses moves ups and down together with the same frequency, and the ratio of their amplitude is that number that we found analytically as well. There, again, I'm going to show it. So that's the first mode, the first natural frequency, and the amplitude of these two masses, as you see, one of them is larger than other, as we managed to find out in simulation, right? That's our first mode, 0.618. The second mode is at higher natural frequency. As you can see, it's 1.618 square root of k over m. And the ratio of amplitude is the negative numbers. It means these two are going to move in, actually, if I make it larger, in opposite direction. And the ratio of their amplitude, again, I showed it there. They are in moving opposite direction. And it's at the second natural frequency, which is higher than the first one. Now, this system, when we disturb this system, of course, it's going to move in combination of these two modes. And here is combination of these two modes. So actually, we combine mode 1 and mode 2 and based on some initial conditions. So I gave the initial condition of 150 to the first mass and minus 200 to the second mass. And here is my result. So if you recall, this simple model actually was a representation of a cantilever beam with two lumped mass. And we also showed that for a cantilever beam, actually the mode shapes following the constraint of a cantilever beam is something like that. So here is the first mode and here is the second mode. And let's just quickly look at the simulation of that as well. So I'm just gonna maximize that for you. All right, so here is our cantilever beam with two lumped mass. And if it moves in its first mode, we expect something like that motion here, as you see. So that's the first mode. And it comes ups and down with a certain natural frequency. And then we are going to have the second mode, which is, like you see, the two masses moving in opposite direction, and the middle mass moves in higher amplitude than the second mass. All right. I hope it was useful. I'm just going to hide that one. I hope it was useful. As you saw, we demonstrate how we can find the natural frequencies and mode shapes of a simple system. Thank you very much for listening.